Welcome to Anduski Lectures. Topic is heat treatment of metals. Now, we have seen the mechanical properties of metal like strength, stiffness, elasticity, malleability, toughness, creep, hardness, etc. Now, heat treatment of metals is basically to obtain these desired mechanical properties. For example, let us assume that the desired properties is to increase the hardness of the outer surface of the metal. For that, we use the process case hardening. Case hardening can be carburizing, nitriding, cyaniding, or carbonitriding. Another desired property, let us assume, to produce a refined grain to induce softness, improve electrical and magnetic properties, and sometimes to improve machinability. For that, annealing and normalizing is good. Now, to achieve greater toughness, tempering, to increase the hardness of the outer surface while the core remains relatively soft, we can use surface hardening. So to obtain these desired mechanical properties, we use heat treatment of metal. Now let us look into one of the process, annealing. Now annealing involves heating a metal to a suitable temperature and holding it there, followed by cooling it at a suitable rate to lower the hardness. So first you heat it and then cool it and lower the hardness. So the steps in the annealing process generally is recovery, recrystallization, and grain growth. Recovery means metal is composed of a lattice of crystal structure that are known as grain. Sometimes the structure of the grains themselves cause stress to the material. During the first phase of the annealing process called recovery, we raise the temperature of the material to a point that removes internal stresses. So to remove internal stress, we use recovery, then recrystallization. During that, heating raises the temperature of the metal to just below its melting point, high enough that the atoms recrystallize. Grain growth. During the grain growth stage, new crystal grains become fully developed as a metal cools. They don't have the metal's original stress. So basically you can see that the annealing process softens the metal. So the purpose of annealing to soften this, for example, steel, to soften steel. Now case hardening. Case hardening, it is to case hardening we have carburizing, nitriding, cyaniding, and carbonitriding. Carburizing process by which iron or steel absorb carbon while the metal is heated in the presence of carbon-bearing materials such as charcoal or carbon monoxide. The intent is to make the metal harder. So nitriding also to make harder, and cyaniding and carbonitriding also to make the metal harder. The cyaniding process, we need to heat the metal object or part of it at high temperature in a bath of sodium cyanide. Thereafter, we need to quench the metal part, following by rinsing it in water or oil in order to remove any remaining sodium cyanide on the metal surface. Carbonitriding also is a type of case hardening in which gaseous atmosphere is used for the hardening process. So the difference is the cyaniding and carbonitriding is that a gaseous atmosphere is used for the hardening process in carbonitriding. Now tempering process. Tempering is performed by elevating the steel to a set point below its lower critical temperature. And the normalizing heat treatment process, it also follows the same steps as annealing process, that is recovery, recrystallization, and grain growth. The process is that the metal is heated in a normalizing furnace to begin, and the normalizing heat treatment process. Normalizing heat temperature of the furnace is kept between 750 to 980 degrees Celsius. It is dependent upon the carbon content of the material. The material is cooled to room temperature in still air or nitrogen. As I already mentioned, that normalizing also follows the 3 stages, same as annealing. And annealing, it is to soften the metal. Thank you for watching the video. Thank you.